in business, there's an important formula, the compound interest formula. And in this formula, amount equals principal times 1 plus, that's your rate, times time. Again, this is for compounding interest. Now, when we look at this, we're going to hold P, R, and T all constant 1. P is your principal, R is your rate, T is your time, typically in years, and that's the way we'll look at it. So if I substitute those values in, P is 1 plus, times 1 plus 1 over, and we'll talk about N here in a minute, N times T, we're holding constant 1. Well, we simplify, remember, multiplying by 1, 1 plus 1 over N times 1 is to the N power. We'll come back to this formula here in a minute. Let's talk about N. N is the number of times we compound per T. And in this case, again, we're going to talk about number of times we compound interest per year. So the first one, if N equals 1, means we compound interest annually. If N equals 2, means we compound interest biannually, meaning twice a year. If N equals 4, means we compound interest quarterly, right? That's why we skip the 3, because you don't really break up a year in 3 parts. Quarters, if you're in investments. If N equals 12, that's monthly, right? 10 doesn't make much sense when talking about a calendar, because calendars break up in 12 months. N equals 52. We're going to look at all of these. This is compounded interest at the end of every week. N equals 365. Compounded interest at the end of every day. Compounded interest, if I take 365 times 24, I get 8760. That's how many times we can compound interest per year if we did it hourly. And even more, if we calculated interest every minute, here's what happened. But remember, it's not like we're calculating a whole bunch of interest. As we calculate it more often, what happens is we divide by. So it's a little bit less interest each time we do it. Now, let's plug in that annually. If N equals 1, let's plug it in. 1 time plus 1 over 1 to the first power. 1 over 1 is 1, plus 1 is 2, to the first power is 2. We can plug in, this is probably one of the last ones we can even do by hand. If N equals 2, 1 plus 1 over 2 squared, 1 half plus 1, that's going to be about 1.5. Squared, 1.5 times 1.5. If we had 15 squared, it would be 225 with 2 decimals, 2.25. Here's where it gets more interesting. We needed a calculator. That's why I even wrote these down, just so we wouldn't waste a lot of time. If N equals 4, 1 plus 1 over 4 to the 4th power. So remember, we're taking the time itself 4 times, but now it's only going to be 1 1/4. So it's a lot less interest each time, but more times. We end up with 2.441406. Now, here's where it gets really interesting. If we do it 52 times. If we do it 52 times, notice, 1 plus 1 over 52 to the 52nd power. When we think of to the 52nd power times itself 52 times, that's a lot of times. But notice what we have here counteracting it is when we have 1 over 52, that's going to be a very small number. 1 divided by 52 is 0.00 something small, plus 1 is just barely bigger than 1. Well, if we had 1 to the 52nd power, that would be almost 1. This number isn't much bigger, so even though we're multiplying it times itself 52 times, what we have is kind of like this balancing act. Yeah, we multiply by itself a lot of times, but it also gets smaller and smaller each time that we try multiplying it. That ends up being 2.6925. Now, for our next one, what if we plug in 365? If I plug in 365, notice I'm multiplying it times itself 365 times. Try doing that by hand if you would like. We use the calculator. 1 divided by 365 is 0.003, something very small too. So when I divide that, I add to 1. Again, I have a number not much bigger than 1, and now it's even closer to 1. So as this number keeps multiplying it times itself more often, this number kind of balances it out, where I think it should be much larger, because 365 times, it actually barely even goes up 2.7. It only goes up 2 cents when we're talking about what this number is going to be. Now, what about when we talk about per hour? When we talk about 8760, right? How many hours there are in a year? So now I'm calculating interest every hour. where we play this balancing act is 1 divided by that is an extremely small number, 0.000023, whatever it's going to be. So we're talking about an extremely small number, close to 1, that's going to be times itself that many times. What we end up with? 2.718. So this one didn't even go up a full cent, right? When we look at those numbers, it keeps going up less and less, even though this number gets so much bigger. Look at that 525, 600. Can you imagine multiplying the number times itself 525,600 times? But when we look at that decimal, that's just going to be 0.000002195. Some tiny number, barely bigger than 1. This is almost 1 times itself. And because it is a 1 point something tiny times itself, 525,000, what we end up with, and you look at those two numbers, and there's almost no difference. Right? It almost even looks like a rounding error when we look at that kind of a thing. What we're doing is, what if we take into infinity? Not just every minute, but how about every half a minute? How about every quarter of a minute? How about every tenth of a minute? As we keep, even if we want to break down in seconds, as we keep breaking down every half a second even, you're going to have an extremely big denominator, barely bigger than 1, times itself an extremely large number of times. What happens is, this number gets closer to and closer to and closer to the number E. The number E is 2.718281828, never repeating, never ending decimal. Now, when we look at this number, this is just like, if you want a good comparison, think of pi. If you remember pi from back in geometry days, pi was 3.141592. We always rounded to 3.14, but it was a never-ending, never-repeating decimal. These two numbers have a lot in common. And we'll talk about some of those later, but we commonly will even just look at that as 2.71. But more importantly, the whole reason we're talking about this, you'll see on your calculator an E button. Sometimes it's a little button up above. Sometimes it'll be a calculator with E to the power of. We see this a lot. And again, the whole reason we're learning this, on our logarithms, you'll see 2 buttons on your calculator. You see where that's log, and you see the button right next to it that says ln. The ln is what's called a natural logarithm. That natural logarithm occurs a lot in our science classes. It's a big character when we start talking about calculus. That log button, chances are you only have log base 10. And the reason it's log base 10 is because, much like our scientific notation, we have a base 10 counting system. That ln is a log base E. That's why you have that E to the power of button on your calculator, because that base of E is very common in a lot of our formulas later. The whole reason we're learning this is we have those 2 buttons. We haven't dealt with hardly a base 10 or a base E. We haven't dealt with a base E this entire term, but here's where we're going to see that is what we need for a base change formula. Let me flip to our next page.